So now we will start with one of the NDT techniques. First of all, before going to any technique, there are two major subtopics here. So non-destructive testing of any material, it can be done for the surface defects or it can be done for volume defects. Sometimes surface or subsurface defects. Subsurface defects can also be done from here. So we will start with one of the surface testing here, surface NDT technique, which is nothing but dye penetrant technique. So this is dye penetrant technique. So in case of dye penetrant technique, there are four major observations, four major steps. So four steps are there in case of dye penetrant technique. Firstly, I tell you what are the four steps. Then we will take care some of important points of these steps. So these four steps are: first of all, you have to clean the surface. Clean the surface to remove any contaminants like oil, grease, etc. Or you can say any dust particle or any dust particle. Okay, so this would be the first step, to clean the surface to remove any contaminants like oil, grease and dust particle, etc. After that, what you will do, you will apply the dye. And then third, you have to take a dwell time. You have to give a dwell time so that whatever dye which you have applied, for example, let us suppose that you have a machine member here which you want to test, and there are some cracks here, and you are applying a dye. Let us suppose this is the dye. So you have to give some time so that this dye goes inside the crack. So that time for which we wait to settle the dye at the crack, in the crack, is known as dwell time. After that, what you have to do, you have to clean the surface again. So actually what you have to do, you have to actually wash the dye at the surface. Wash the dye at the surface. And please note that you don't have to remove the dye inside the crack. Don't remove the dye inside the crack. Remove the dye inside crack, or the defect or flaw, whatever you can say it, or a defect. So wash the dye at the surface, and then finally what you have to do, you have to go for inspection. So these are the 5 steps which are required in case of a dye penetrant technique. Now we will see some important points related to these steps. Okay, so firstly there is a cleaning. Okay, so these were the 5 steps. Firstly was cleaning. Now let's start with the basics, that how this dye technique works. These were the 5 major steps which we follow. Now firstly is, let us suppose that you have a surface here, and what you have done, a liquid droplet is being dropped by you. Now these liquid droplets can have different surface energies here. For example, this one, this and this. Let us suppose this is a liquid droplet and this is your solid surface. So this is L, this is S. So these surface energy, and this is nothing but your outer space. Your outer space. Let us say vapor will be there. So this will be, let us suppose, gamma LV. This will be gamma ls, and this will be gamma sv, where gamma represents my surface energy. Surface energy. So gamma LV would be surface energy of liquid and vapor interface. Liquid vapor interface. And same thing for other also, SV and LS. Let us suppose that this angle is theta. If this angle is theta and you do certain geometric calculations here, then you came to know that gamma SV is nothing but gamma SL plus gamma LV cos of theta. So if this has been shown here, that if this theta is less than 90 degree, then your droplet would spread in the surface. Your droplet, or we can say the liquid, will spread on the surface. Whereas if theta would be greater than 90, then what will happen? That liquid will not spread, but liquid will repel the surface. These type of surfaces might you have been seen in some glasses, in some hydrophobic, example I am giving, hydrophobic coated glasses, hydrophobic coating on glass. So this is theta greater than 90. Now let us suppose that if you have a particular machine member or a particular element here, and there is a crack at this side. Let us say this crack is C. This is the crack or any defect. So if you have spreaded a die, so first of all, what should be there? Your theta should be less than 90. First thing. Secondly, what you should know, that if dye is penetrating inside, if you want the dye to penetrate inside this crack, then what are the first condition? First of all, there should be some downward force which attract this dye to the crack. So what is the name of that downward force? This is nothing but the downward force is known as surface tension, which you have already been studied in your plus 2 level, surface tension. And surface tension is nothing but your surface energy. Surface energy for this liquid vapor interface. Okay? So now let us draw this here. So what you are seeing here, that if, let us suppose that this is a pure vertical crack, it can be of any shape, and let us suppose this is the die, and you have filled the die. Actually, so this die that is being attracted to the downward side due to the surface tension force which is acting there. So this is nothing but here if you do, this is the same capillary force. So let us suppose that the surface tension which is acting is sigma here. Let us suppose. So at this particular point I will do this same analysis which I have shown here. So here what would happen, that your gamma, this will be your surface tension force here. So its value will be 2 pi r gamma LV cos of theta. So it is very simple. Why? Because let us suppose that this is 2r, where your radius of this particular crack or defect, what you say, is r. So this would be 2r. So this is nothing but 2 pi r into this gamma LV, and then this angle is theta. This is nothing but the same angle theta which I have shown here, nothing but contact angle. So this force this force which actually drive this die to the defect is working like a capillary, which you have studied in your plus 2 level. So this force is also known as a capillary force. So although we are using the concept of surface tension, but the force which actually works is nothing but capillary force. So these are actually analogous to each other. So let us suppose this is 2 pi r LV, gamma LV cos theta. So this force would be balanced by the weight of this particular liquid. Let us suppose that this is height h. So whatever force would be there, it would be balanced by this surface tension. So this would be pi r square h rho g. Now if I equate these two, then what would I get? I would simply get 2 pi r gamma LV cos theta. That should be equal to your pi r square h rho into g. So just equate this, so you will get the value of h. So it is nothing between 2 gamma LV cos of theta upon r rho g. So now you know the height. If this is the particular height of a particular crack or a defect, then what would be the crack radius and gamma LV and the contact angle. So this is the relation between your crack height and surface tension of a particular die. So whatever die you are taking, let us suppose that the surface tension of the die is gamma LV. So how much height would it penetrate inside the member? This is given by this formula. So now you know this. Now let us move to another. So right now we have studied some very basic thing about the liquid die penetrant technique. We have studied about what is the relation between the crack defect height and surface tension. Now let's move to another thing. So why do we need cleaning? This was the first step, cleaning. First step was cleaning. Why we want to clean the surface? The reason is because if you don't clean the surface, then this liquid dye won't be able to spread easily. If you won't do cleaning, then this liquid dye particles can't spread easily on the surface. So this was the main thing. This was the main reason why we were doing this all cleaning. So this cleaning you can do sometimes by washing with the water or any detergent. Okay. So this was the main step for cleaning. Now we'll move to dwell time. So after you have filled, let us do the dwell time. After you have applied a dye here, let us suppose that this is the defect and you have applied the dye. Then we have to give certain time so that dye can go inside this crack or defect. So why we want to give this dwell time? Because every liquid has a particular viscosity. And due to this viscosity, what happens? That fluid takes some time to take a particular shape. That's why we want to give a particular dwell time here. And what we actually need, the viscosity, what we actually want, that viscosity should be low. Why? Because if viscosity would be high, then it would take high amount of time to fill this gap. Correct? So that's why we need to have a less dwell time, we need viscosity to be low. And generally this dwell time varies between 10 to 15 minutes something. And for small samples it can be around 5 minutes only. For small samples. But generally this is the dwell time.